Hi, welcome to Fornet by Videos. This is DC here. In this video, I'm going to show you how to use Tagit HFI plus IS15693 tag using the OmniKey 5022 reader writer. This is the continuation of my previous video where I showed you how to use the IS15693 tags, and in the last video I have used the NXP iCode SLI. In this video, this is from a company called Texas Instruments, and it is referred as Tagit HFI plus. So these are some of the important features of Tagit tag. So any write or any kind of a changes you do requires the option flag is equal to 1. If you compare this with a tag from NXP where the write operation is done using either the option flag is equal to 0 or option flag is equal to 1, whereas in this Tagit the option flag is always set to 1. So this is the root cause of some of the issues using this tag with the OmniKey 5022 reader writer. So when the option flag is set to 1, this is how the write operation is done. We first send the write block command. The tag doesn't return any response. After that, you have to send the end of frame command to receive the response from the tag. In the normal write operation, when the option flag is set to 0, soon after the very first write command, the tag will return the response, whether the write is successful or not successful. Whereas with option is equal to 1 flag, the response is returned only after the reader sends a second command which has got only the end of frame. I'm going to show you how this is explained in the standard document. Now what I noticed is in OK5022 reader writer there is no command to send just the EOF. Now in my last video I showed you how to use a transparent session, because without the transparent session you cannot send the tag specific IS15693 command. Now there is a workaround for this. The workaround is don't send EOF, just send the write command and send any other command. So when we do this type of workaround, you have to ignore the error you might get in the first command, because the write single block command does not return any response. So you'll come to know about this when I demonstrate this tag. So if this is a bit confusing, just keep in mind, just this having the option flag is equal to 1 has got an issue with this reader writer. What I also seen is the OK5022 does have an update binary command. This is the command in the firmware. If you use this update binary command for the write operation, then the firmware internally handles this EOF and it returns you the success or a failure response immediately. Now you're going to see how to use all the commands of Tagit HF1 plus, and by the end of this video you will know, you'll be very good in understanding those commands. And as I mentioned before, you have to see my previous videos before you see this thing. So this is the data sheet of Tagit HF1. These are the commands that are supported by this tag. If you look at the write single block command, it says the option flag is always set to 1. Likewise, lock a block, you must have the option flag set to 1. And wherever you see this option flag set to 1, you'll have a problem sending those commands in the using the transparent session of 5022 reader writer. Even though the custom commands like write 2 blocks, lock 2 blocks, which also needs the option flag set to 1. If you look at the standard, the documentation of this of 15693 part 3, now there is an explanation about what the reader device or the VCD device should do when option flag set to 1. I'm just going to read this out to you. It says, if the option flag is set, the WIC shall wait for the reception of 100% modulated EOF frame from the VCD. Upon such reception shall return the response. Now here, if you look at the scenario where option flag is not set, the WIC returns the response immediately. This is the scenario where the option flag is set to 1, where the WIC means here the tag, the S1569 tag. The tag will return the response only after reception of a 100% modulated EOF frame. Now this is the root cause of the problem here. Now there's no way you can send these type of frames using this 5022. If you are following all my videos on IS-15693, so I've shown how to use the PN5180 reader writer, and in there this reader writer supports or has a command to send the EOF only, whereas it's not available in 5022. So this is the background you have to have. Then next I'm going to show you how to write to a tag. So the version of software I'm using here is 2.3. If you look at the release notes, now it is the latest in 2.3 says added the target tags. Now there are few changes to the screen compared to my previous videos. So if you go here and choose this last option, now if you remember in the last video I mentioned about designing a full screen, a full window screen. So to be honest, we realized it is really difficult to make a software running on a full screen, so because of different screen sizes. So it will be easier to make a screen with a fixed width. So there are a couple of changes, some controls are moved from here to there, and the most important thing, the command set which has gone to the right, and this has got a splitter. You can expand the size of this command window. Sometimes if you know all these commands, you can just collapse it and probably make more space here. Right now there's nothing here, so when we do this SLIX2, you will end up seeing more controls. Okay, so the first thing here is I'm going to place a already used tag. This is not a new one, and keep in mind in my last video I mentioned about you have to enable the IS-15693 protocol in this reader writer, so you have to do that. I showed you how to do that using the HID the configuration software. So I'm going to connect it. Now this we have seen in the last videos, all the commands that are going through the exchange between the reader writer and the software is all shown here. Now this ATR, if you go, there is a website called ATR string, this one. If you paste that ATR, if you paste that ATR and search, now you will come to know that this is the ATR of a target card. Now I use this very often. Using the ATR you can find out what type of tag is that, and also this is a simple data structure. There are many documentation on internet explaining how you can decode these bytes and find out what kind of tag is that. So next, after that, click on a get. This will bring up the number of blocks, 64. The block size is 4, and I'm going to read everything from the tag. There are 64 blocks. All these 64 blocks are read here, and I'm going to just I'm going to write. Now if you remember, all the write operation or any changes to the data must have the option flag set to 1. So that is how the tag it works. I'm going to change this this data of block 18, and before that let me get the status of the lock. If I hit this multiple secret status button. If you have been following my videos on PN5180, I already mentioned how to use this tag it. So more or less the concept is the same. Now I know that by hitting this is a standard command to read only the lock byte of all these 64 blocks. So I'm going to change the value of block 18. Oh, this is locked, I can't change this to block 17. I'm going to set all as 0. Okay, I'm going to clear this thing for a while. Now if you hit, now the software says you must have the set flag is equal to 1. Now without flag is equal to 1 you cannot write. So the software is just is preventing you from writing because write doesn't happen without this flag. So go to option here, click set, and write. Now as you can see here, the very first write single block command returned a error message. So this 0600 is an error. If you look at the documentation of OK5022, you can see that the first 2 bytes, 06 means it's a HID timeout error. You must have the first byte as 00 to have a successful write operation. So this is the one. So because this, even though you get an error, so the write operation has done its job. The tag is indeed been updated with this new value. It's just because there's no way to get this response. Think about that. The very first command, the write block command, does not return any response. So 5022 have been waiting, finally didn't get any response. Then it's shouting saying that, oh, there is a timeout. Because the tag will return the response only after sending a end of frame command, which you can't do using this transparent session. Okay, so because what the software is doing here is, soon after the write, it's trying to read the same block, and the read has returned the value we have the read has got the response, so which should match what we have written here. So sometimes the read may not match because the block could be locked. So this is how you do the write operation. Use the write, you send all these if you can. Let me give one more example here. I'm going to write here. I've just removed the command wrapper. Now this is the ISO 15693 write single block command, and this is the response we got, and this is the ISO command for read a single block, and we got the data that we just wrote. So likewise, to lock as well. So I'm going to lock this bit. So give a lock. Again, if you don't click this option, the lock will shout at you saying that the option flag must set to 1. So here, lock, it's saying keep in mind the lock is just a one way, you can't undo it. So here also I think the lock has not done the read operations. Okay, now if you try to read, now you can see that read with the option flag set to 1 will return you the data and the flag. Now what the software should have done is, it should have after the lock operation, it should have tried to read with this option, so that you could have easily seen this. So next thing is the write two blocks and lock two blocks. These are the custom commands of Target. So I've explained this these two custom commands in my video on P15180 board. So I'm going to show you here. You're just going to see that the normal write two blocks will return a timeout error, which you can ignore because we know the write has indeed happened. It's just because the reader did not send the EOI frame, or doesn't know, just it doesn't support EOI frame, there's no way you can get this response. Now I'm going to write these two blocks. Now I'm going to set this as zeros. Now this is the custom command where you can write two blocks at a time. Now I want to write two blocks 15 and 16. Choose this. I don't think 15 is probably not there. You have to write the even address, I suppose. Go with the 16 and 17. Probably I think the address should be an even number, which I have mentioned in my other videos. So write again. This is the custom command. The manufacturer code of Target is 07. It's over here. So the read, again, this is return the timeout error, but the write two blocks return timeout error. But what the software is doing here is it's trying to read the block 16 and the block 17, and if you look at the response, it is indeed what we have just wrote. So this has proven that the write two blocks is successful. So that's the reason why I mentioned that you can ignore this error. So likewise you can lock as well. So I'm going to lock these two blocks again. The 16 and 17 I'm going to lock it. Right now there should be a warning here, which probably I tell my developers to put that warning. Now here this command is doing what exactly I mentioned before. It tries to lock, it sends the lock two block command to lock 16 and 17, and after that it's trying to read the single block with the optional flag set. Now this is going to return you 5 bytes. The first byte is the lock status, which is 01 is locked, and the remaining 4 bytes is the data. So now we know that how the lock two block works. Now one more thing I would like to show you here is, as I mentioned before, the 5022 reader can read and write to the target or any ISO 15693 tags. I think in my last video I made a mistake saying that 5022 could not write to target, so I apologize for that. Okay, so I'll tell you now, because of the software did not let you write it, but I'm going to show you after this the small change we made in the old screen is this screen, where you can use that old screen to write to the target. Now this time I'm going to use the standard update binary command. 5022 supports ISO 15693 tags read and write. However, it doesn't directly support sending the custom commands. To send the custom commands, you have to use this the transparent session exactly the way we have used in the software. Next I'm going to show you this little feature we have added. Now if you put a tick here, you're telling the software not to send the ISO or the low level commands, rather to use the standard PCSC, the update binary command. Now I'm going to write, to go for example, say block 39. I'm going to write block 39. Now here, if you're using the standard command, you don't have to worry about any of these flags, because this is using the command which is in the firmware of 5022. If I hit 8W. Now this is the update binary command. Now this is the very standard command. Most reader writer will have this command because this is the standard. It's a PCS standard way of updating any RFID or NFC tags, and the response is 9000. So if you what you can do is, because this is learning software, this software tells you how to use the standard command, how to use this card specific command. But if you are doing your own program, I would advise you to use the standard command. It's pretty easy. You don't have to worry about setting the option flag or setting these flags. Just a simple command. So likewise, in order to change the AFI or change the DSFID, you still have to have the option flag set to 1. Now these tags have already locked AFI because this was used in the previous demo. However, I've already seen this working on a different tag, because one thing with this the tag it's not easy to find on internet. So I have got few cards which probably I've already spent most of them. I'm going to use, probably this is a different tag. Whenever you change the tag, you just have to go and hit this connect and get this. You get a different ID. Oh, not sure. Oh, sorry. The reason why we got an error is the option flag is set to 1. Now this is the get information. I'm going to read clear, and I'm going to change the value of AFI set. Now keep in mind, you have to have this option flag set to 1. The software is telling you to do that. Set. It is an error because I already locked this AFI. I'm going to show you how to lock this DSFID. I'm sure the DSFID is not locked. First, I'm going to change the DSFID to say 10. Set. Now you can see here, this is again here probably the software should have done the read operation. Maybe it's a reason why this was not done. So you can see here, write DSFID command return an error message. If you go and hit this get, remember we just changed to 10. If you hit this get, you can see that oh, this thing, okay. If you hit the get, you can see that the write is indeed successful. It is just because we are not able to send the EOF frame. So likewise, you can lock it. I'm going to lock. So option flag set to 1. Lock. Now here also this returned an error. So however, if you try to, I'm sure this is locked. If you try to change the value to something else, set, you will get error message. So this proves that DSFID is indeed locked. And all these commands, I've explained this in my other videos. I think most of the thing you have to know about using a target with the 5022. I think we are covered. And keep in mind, it is not just the target. If you worked with the future version of these iCode tags like iCode SLIX or SLIX2, even these tags, they do support the write block command or all these setting AFI and setting DSFID command with the option flag either set to 0 or set to 1. It's just the tag which supports all the write operations only with option set to 1. Whereas in NXP, SLIX, SLIX2, you still have the option set to 0. So you better stick with with 0. Easy for you to read and write. Okay, that's all in this video. Thanks for watching.